Okay, Assalamualaikum warahmatullahi wabarakatuh. I am Latifah Muhammad Noor. I'm going to explain to you how to answer practice 3.1, page 87, question number 1 in the General Chemistry course book TST0914. So this question asks us to sketch the energy level diagram. Okay, energy level diagram. And draw arrows to show the transition of electrons, okay, of the hydrogen atom for the second and the fourth line in visible region. So firstly, we need to know what is the series of this line. Okay, so we refer to the region right here. Okay, so the region given is visible region. So visible region is the Balmer series. Okay, where the ground state of Balmer is N1 equals to 2. Okay, so from there, we can determine what is the N value for the second line of Balmer series. Okay, the N value is, okay, the ground state of Balmer is N equals 1. Therefore, the first line of Balmer is N equals to 3. The second line of Balmer will be N2 equals to 4. Okay, the transition of the second line. Okay, the transition means when the electron fall back from the higher energy level to lower energy level. So the transition of the second line of Balmer series must be from N2 equals to 4 to N1 equals to 2. Okay, so that's for second line. The fourth line of Balmer series. Okay, what is the N2 for fourth line? Okay, if second line is N equals to 4, the third line will be N equals to 5, the fourth line will be N equals to 6. Okay, so the transition is for the fourth line is N2 equals to 6 to N1 equals to 2. Okay, so from there we can sketch the energy level diagram. Okay, so the energy level diagram is a graph, okay, where we have the energy. Okay, we have energy. Okay, so we have to label here energy. Okay, versus the ground state. So ground state of Balmer just now is N equals to 2. Okay, so before we can go to the second line, we have to draw the first line. So first line is N equals to 3. N equals to 3. Okay, and then we go to the second line, which is N equals to 4. Okay, so we want to form 4 lines, so must have 4 lines in our energy level diagram. So another line is N equals to 5, and last one N equals to 6. Okay, make sure the distance between the lines becomes smaller. Okay, the distance becomes smaller because as the energy increase, the wavelength will decrease, the frequency will increase. So now how to show the lines, the transition, the arrow of the transition of line, second line and fourth line in Balmer series. Okay, so we have to draw an arrow downward arrow. Why downward arrow? Because the line is only formed when the electron fall back from higher energy level to lower energy level. So we draw arrow downward. Make sure you use ruler when you draw this. Okay, so label this as second line. So this is the transition of the second line in Balmer series from N equals to 4 to N equals to 2. Okay, and then for the fourth line, we draw from N equals to 6 to N equals to 2. So this is the transition of the fourth line in Balmer series. Okay, for question B, we want to calculate the value of wavelength, frequency, and energy for the second line of Balmer series. Okay, question B, we want to calculate the wavelength. The wavelength is lambda, the frequency and the energy. Okay, so how to calculate the answer? Okay, firstly, I will rewrite the information that we have for second line in Balmer. Okay, we have the transition N2 equals to 4, 2, and 1 equals to 2. Okay, so the wavelength can be calculated based on this information. The wavelength can be calculated using this formula. Okay, 1 over lambda equals to RH 1 over N1 square minus 1 over N2 square. Okay, so the N1 value must be less than the value of N2. Okay, so we can substitute the RH value for calculating lambda is 1.097 times 10 to the power of 7 meter per meter. Times 1 over 2 square minus 1 over 4 square. So why we use this formula? Because the information that we have is only the value of N. Okay, so we substitute. So remember, this one is 1 over lambda. This is 1 over lambda. So make sure you be careful when you calculate the value of lambda, not 1 over lambda. So the answer will be 4.8617 times 10 to the power of negative 7 meter. Okay, so that's the value of lambda. Okay, so next, using the value of lambda, we can calculate the value of frequency or nu. Okay, so how to calculate the value of the frequency nu? We use the formula C over lambda. Okay, so we substitute. C is speed of light, 3.00 times 10 power of 8 meter per second. Okay, times, over lambda value that we have calculated just now is 4.8617 times 10 to the power of negative 7 meter. So we cancel the unit meter, we will get the answer of the frequency equals to 6.1706 times 10 to the power of 14 per second, or another unit of frequency is hertz. Okay, next, how to find the value of energy? Okay, based on the information that we have just now, second line of Balmer. Okay, second line has transition N2 equals to 4, 2, and 1 equals to 2. Okay, so based on this, we can use the formula delta E equals to RH 1 over N1 square minus 1 over N2 square, where the N1 is equals to, the N1 should be less than N2. Okay, so we can substitute. The RH is the RH to calculate the energy, which is 2.18 times 10 to the power of negative 18 joules, okay, times with 1 over 2 square minus 1 over 4 square. So we will get the value of energy equals to 4.0875 times 10 to the power of negative 19 joules. Okay, this is one of the way to get the answer. Okay, besides using 1 over RH 1 over N1 square minus 1 over N2 square, okay, we can also use the formula of delta E equals to HC over lambda. Okay, if you still remember, okay, we have also calculated the value of lambda before. Okay, so we substitute the H value, which is Planck constant. So it is 6.6256 times 10 to the power of negative 34 joule second. okay, times c, speed of light is 3.00 times 10 to the power of 8 meter per second. Okay, over the lambda value that we have calculated just now is 4.8617 times 10 to the power of -7 meter. Okay, so we cancel all of the unit that we can cancel, meter and second. Okay, we will get the answer, which is equals to 4.0884 times 10 to the power of -19 joules. This answer is also correct. Okay, another way, okay, one more method that we can use is calculating the value of delta E, okay, using the value of frequency. Okay, we have also calculated frequency just now. Okay, so delta E equals to h nu. Okay, so we substitute. Nu is 6.6256 times 10 to the power of -34 joule second times with nu that we have calculated is 6.171706 times 10 to the power of 14 per second. Okay, you will get the answer equals to 4.0884 times 10 to the power of -19 joules. Okay, so this answer is also correct. So 3 methods to calculate the value of delta E. Okay, so all of the answers are correct. But which method is the best method? Okay, for me, the best method is this one. Okay, the first equation here. Okay, why we use RH 1 over n1 square minus 1 over n2 square. Okay, why this is the best? Because these are the information that we have from the question itself. Okay, so if you calculate using hc over lambda or h nu, okay, your answer is still correct. But if let's say you got a wrong answer for the lambda value here, it will affect your answer, okay, for the delta E. Okay, if you get wrong answer for mu values, you will get wrong answer for the delta E. So the best is using RH 1 over n1 square minus 1 over n2 square based on the information given in the question. Okay, so that's the answer for number 1.